Hey everyone, it's AJ here, and today we're diving into the world of serverless computing with Azure Functions. Serverless might sound misleading, but servers are still involved. With serverless, you don't manage them. Azure Functions handles the infrastructure. They are pieces of code running in the cloud. Think of them like little apps performing tasks. Tasks like processing data or responding to HTTP requests. Focus solely on your code. Azure Functions handles provisioning, networks, and scaling. It's all about efficiency and scalability. Build and deploy applications faster and more cost-effectively. Before we dive into the nitty-gritty of Azure Functions, let's talk about function apps. A function app is like a container that holds one or more Azure functions. It's a way to group related functions together and manage them as a single unit. Think of it like this. A function app is like a folder on your computer. Inside that folder you can have multiple files, each representing a different Azure function. Each function within a function app shares the same resources and configuration. Function apps provide a convenient way to organize, deploy, and manage your functions. They also offer features like custom domains, authentication, and monitoring. When you create a function app, you specify the location where it will be hosted. This location determines the data center where your functions will run. In essence, function apps act as the foundation for your serverless applications. They provide a structured environment where you can develop, deploy, and scale your functions seamlessly. Now let's talk about the heart of Azure Functions, the functions themselves. An Azure function is a self-contained piece of code that performs a specific task. It's the building block of your serverless application. What makes Azure Functions so powerful is their event-driven nature. They are triggered by specific events such as an HTTP request, a message on a queue, or a change in a database. When a trigger occurs, it invokes the associated function, which then executes its code. For example, you could have a function that triggers whenever a new file is uploaded to your storage account. This function could then process the file, extract relevant information, and store it in a database. The beauty of this approach is that your functions only run when they need to. This makes them incredibly efficient and cost-effective, as you only pay for the actual execution time of your code. Section 4. Exploring triggers, initiating your functions. Triggers kickstart your Azure functions. They act like listeners, waiting for events to invoke functions. Azure Functions supports various triggers for different services. A common trigger is the HTTP trigger. It invokes functions via HTTP requests. Another is the timer trigger. It schedules functions at specific intervals. Ideal for background tasks and notifications. Blob triggers fire on new or updated blobs. Queue triggers activate on new queue messages. Section 5. Bindings. Connecting to data and services. Bindings in Azure Functions provide a simple way to connect your functions to various data sources and services. Bindings act as bridges, allowing your functions to easily access and interact with external resources. For instance, you can use an input binding to retrieve data from a database, a storage account, or even a third-party API. This data is then passed to your function as parameters, making it readily available for processing. Similarly, output bindings allow you to send data from your function to external destinations. For example, you can use an output binding to store data in a database, send a message to a queue, or update a document in Cosmos DB. Bindings simplify your code by abstracting away the complexities of interacting with external services. They handle all the heavy lifting, such as authentication, connection management, and data serialization. Section 6. Execution context. The environment of your function. Every time an Azure function is triggered, it runs within a specific context known as the execution context. This context provides your function with valuable information and tools to interact with its surroundings. Think of the execution context as the backstage pass for your function. It grants access to details about the trigger that invoked the function, such as the request headers, the message payload, or the timer schedule. Moreover, the execution context offers utilities for logging, managing function invocations, and accessing application settings. It also provides a mechanism for your function to communicate back to the Azure Functions runtime. Understanding the execution context is crucial for writing robust and efficient Azure functions. It empowers your functions to make informed decisions based on the context of their execution. In this final chapter, let's dive into a complex example of using Azure Functions in a real-world scenario. Imagine you are building a serverless application that processes images uploaded by users. The function will automatically resize the images, apply filters and store them in a cloud storage service. First, let's set up an HTTP trigger that activates whenever a user uploads an image. This trigger will capture the image file and pass it on to our function. Next, within the execution context, the function will utilize Azure Blob Storage bindings to access and store the image. Using the context, we can easily extract the image file from the request and save it to a temporary storage location. Once stored, the function will then call an image processing library to resize the image and apply filters. This could include resizing to multiple dimensions for different use cases, such as thumbnails or high-resolution images, and applying filters to enhance image quality or add effects. Finally, the processed images will be uploaded back to Azure Blob Storage, organized in a way that makes them easily accessible for future use. The function will also log the process, ensuring that any errors or important events are recorded for future debugging and monitoring. This example demonstrates the power and flexibility of Azure Functions in handling complex workflows seamlessly. By leveraging triggers, bindings, and the execution context, you can create sophisticated serverless applications with minimal effort. To conclude, Azure Functions offer a robust and scalable solution for building serverless applications. With its wide range of triggers, bindings, and integrations, you can create powerful and efficient workflows that meet your business needs. Thank you for joining us on this journey to mastering Azure Functions. Happy coding! By watching this video, you are supporting Anand Foundation's mission to provide educational programs for underprivileged children and their families.